Hi, APE students. Good morning. We're going to talk about solar energy today. I split Chapter 13 on renewable up into the different types of renewable energy to make sure we could get through the videos in a pretty timely manner. So if you don't yet have your packet open to this page and you have not yet opened the PowerPoint from Canvas, just stop the video for a second and go ahead and do that so you can follow along. We start off with a quick discussion on which forms of energy are ultimately related to solar energy. And as you can see, almost all forms of energy ultimately come back to energy from the sun, which is really, when you think of it, because of photosynthesis, the driving force of energy that runs our planet, and why most people believe that it really is one of our greatest potentials for solving our energy problems. So the only forms of energy that really aren't solar energy are nuclear fission, that splitting of a uranium-235 atom. Remember that those isotopes of uranium that came up at that molten material came up at a divergent plate boundary, deposited that uranium, and that has nothing to do with solar activity. The other form, two forms of energy that we'll look at in this unit that are renewable are geothermal. Again, heat from within the earth that is related to the dynamic processes that form the earth, not that external incoming solar radiation. And finally, tidal power. Just to be clear, and I think we mentioned this when talking about fossil fuels, that these are the remains of ancient plants and algae, and ultimately the carbon that we now harvest and burn in a combustion reaction, that those carbon organic compounds were formed through the process of photosynthesis driven by the sun. Solar energy is obviously solar energy. In terms of wind energy, what creates wind patterns? Uneven heating of the Earth's surface by the sun. And hydroelectric power is also a form of solar energy indirectly, because what drives the water cycle and ultimately hydroelectric power? The sun. And then again, biomass, which we'll talk about in this unit, whether it's wood or charcoal or manure used in much of the developing world, or the liquid biofuels that we'll focus on later in this unit, all driven by photosynthesis processes driven by the sun. So when you look at in your packet at that charter diagram that shows how we have to break down all these different things we do with solar energy, we really say, okay, we can heat with solar energy or we can generate electricity. Remember, we have three basic things we use energy for. We use it for generating electricity, heating, or transportation. And ultimately, if we can have battery electric vehicles that are recharged through solar energy, we can really use solar energy to fill some portion of each of those three sectors of our energy economy. So let's start off with heating and what we call passive solar heating. And the big idea here is that in passive solar heating, all I do is capitalize on the amazing energy from the sun. I don't have any device that actively stores, concentrates, or converts that solar energy. So passive solar energy is almost all the way I design my home or my building. A lot of green architecture focused on passive solar energy. So in this diagram, I can see that I designed my home with big windows that are facing south. And this isn't clear on here, but that's something that you need to know. That I want my big south-facing windows to capitalize on the majority of that solar energy. On the north side of my home, I want really tiny windows. Notice that I have really heavy insulation for energy efficiency, to keep heat in the winter and cool air from air conditioning in the summer. The basic design of my passive solar home is, if I follow the path of the sun in the summertime, I have this overhang that blocks a lot of that sun during its path in the summertime, but when the sun is lower in the sky in the wintertime, that sunlight is coming in through the window and really thick triple pane windows that allow, like a greenhouse, that allow that UV light to come in, but that heat or infrared radiation gets trapped in there. You can take a look at this really cool little link that shows you a passive solar home and how that energy is used throughout the winter and the summer. Note that in a lot of images that you look at of passive solar heating, you're going to find that they show trees and things that are shading that in the summer to provide shade and reduce my air conditioning costs. Passive solar heating is putting clothes on a clothesline and letting them dry them. I don't have any device that's actively storing, concentrating, or converting that solar energy. Just visiting with my daughter, who's in Kenya right now doing a cervical cancer screening program for women. Unfortunately, she's going to have to come back early, but this is an image she sent of how they dry their tools in the sun after they wash them, and then they'll sterilize them with alcohol. So active solar heating, this is just a nice map from chapter 13 in your book that shows me where I have different kilowatt hours per meter squared per day. That unit should pretty much make sense to you now. In other words, how much electricity can I generate per unit area? Not surprisingly, we have very high solar power potential in the desert Southwest as well as in Hawaii. But you'll be surprised to find that even up here in north central Wisconsin, we do have solar capacity. So in active solar heating, I have a device that is actively capturing, collecting, storing, or converting that solar energy. So this is not a photovoltaic cell. That's one of the most confusing things as we look at solar energy, that when I have active solar heating, this is just a panel on the roof of my home in this example, and it's got a liquid. It could be like an antifreeze. It could just be water, something that has a high heat capacity. It's just this panel that has tubes filled with liquid. The sunlight heats that liquid. That liquid is transferred to really a hot water storage tank. And I might have a pump then that can pump that heat out, or I can just use, that's my heat exchanger here, to actually heat my room. Some passive solar heating, that energy is collected in this water tank, and then below my floorboards, I might have pipes like this that are running that hot liquid through there and ambiently heating the air in my home, or I can pump that out with a fan and distribute that heat. Here's an example of women in sub-Saharan Africa using solar ovens to heat water to disinfect it or to cook their food. The other thing that we do with solar energy is generate electricity. So I heat my home either passively or actively. I generate electricity on a very large scale using what is called concentrated solar thermal. And some of you in class actually saw part of this video. There are these huge, this one is in Spain, but there's these huge open kind of desert areas with massive mirrors and this central collecting tower. And these mirrors concentrate that heat energy. The heat that is captured in there heats water, which makes steam, which turns a turbine, which generates electricity. I know that some of the students that went to Spain last year were able to see this big solar thermal tower in Spain. The other way I generate electricity, the most efficient way, is through a photovoltaic cell or a PV cell. And in the energy efficiency lab that you've already done, we had a station on that. So you're a little bit familiar with how a PV cell works. Remember, this is different than that. So I don't like the word solar panel that they use here in your textbook, because we really want to make sure that we're equating a solar panel with active solar heating. And we just want to call this a PV cell or a photovoltaic cell. Just wanted to point out a couple of links that I put in here in the video. I talked about that one a little bit, letting you see passive solar. This is a really great one on solar hot water heaters. It's a National Geographic site that goes to Egypt and gives you an idea of how using like reusable materials, they're making very inexpensive solar hot water heaters. Um, Here is a great link to the Switch Energy video, and you can watch whichever of those solar videos that you want. Take a look at what's happening with solar energy in Wisconsin and this idea of a solar farm or a solar array field. This is a really simple video or image of one I took of a solar array field just outside of Minneapolis. And as we wrap up this chapter and talk about smart grid and localized grid and being able to get my power to the grid on a small scale, we'll come back and look at how these small scale solar arrays or even small scale solar farms are providing energy to individual homes. Good luck with solar energy. I'll see you for wind in a little bit.